So 3.2 is truth tables for the negation, conjunction, and disjunction. Okay. And so really a truth table is used to determine when a compound statement is true or false. Okay. So best thing we can do is kind of work through some examples, but again, our statements, I may not be able to tell you right at this moment whether it was true or false. I don't know if we're going to go to the movies. I don't know if we're going to go to the gym. Could be true or it could be false. So if I'm combining all of those things based on what its set truth value was at the beginning, tells me what happens when I combine them all in the end. So what we do to set up truth tables, we're going to start with just our negation. You start with statement P, and then we're going to look at the truth value of not P. So at the beginning, P can be true or false. So we use 2 rows in our table to keep track of the truth values. Because you only have 2 possibilities. Statement P could be true. We could go to the gym, or we might not. So it's true or it's false. What this end column is then asking is not P now true or false? Based on the starting truth value of P. Okay, so if P starts out as true, its negation would turn to false. If P starts out as false, its negation would turn it to a true statement. So this end gives you every possibility of combinations of truth values. If I start out with true, after combining all this stuff, my end statement would be false. If P starts out as false, its end statement is going to be true. So negation flips those truth values. All right. If we move into our conjunction, that combines 2 statements, P and Q. And what we're going to do is ask, is P and Q true? Okay. So based on the beginning combination values of P and Q, is this final thing true or false? Okay. So we have a lot more possibilities when there's 2 statements. One possibility is they could both be true. Okay. So if they start out as true, when I ask the question, is P and Q true? It is. So this end statement would be true. Another possibility for my starting statements is P could be true, but Q could be false. So this is another possibility at the start. And in that case, when I ask the question, is P and Q true? It's not. They're not both true. So this final statement would be false. The opposite could happen. P could start out as false and Q could start out as true. But regardless, in the end, when I ask, is P and Q true, they're both not true. So this compound statement would then be false. Okay. And then I have one more possibility for my starting truth values. They both could be false. And if they're both false, when we ask the question, is P and Q true? No, it's not. So that end statement is going to be false. Oh, what just happened to all of my stuff? So this end statement would be false as well. So in these three, when we ask our questions, both P and Q are not true. So my end column is false. Okay. And so this is my only possibility for initial truth value. This is not going to change anytime I have two statements. P and Q have truth values of true or false. So I'm running through, think of it, all of my combinations of their truth values. So there's two possibilities for P, two possibilities for Q. I have 4 combinations of them in total. The statements could both be true. One could be true, one could be false, or they're both false. Based off these initial combination of truth values, you can then say what happens for this compound statement here. So this is what a truth table is going to look like. You're going to start with however many statements at the beginning, apply a bunch of different compound stuff, and you're seeing, is this end compound statement going to be true or not? So if we look at our conjunction, that end, the only time the conjunction is true is when both statements are true. So conjunction is only true when both statements are true. Okay. So this is a little hard to wrap your brain around. I totally understand that it can be quite confusing to start out. You're going to notice most of these are going to be similar in the setup. But anytime we have two statements, there are 4 possibilities or 4 possible combinations for their truth values. Because they both could be true. One could be true, one could be false. They both could be false. So let's try our or. If I start with the statements P and Q, is our or statement true? Okay. And again, we have 4 possibilities at the beginning. Oh, geez, wrong thing. So let's make our truth table for the or. Okay. Running through all possible combinations of our starting ones, they could both be true, one false, one true, both false. And at the end here, we're asking, based on the starting truth values of P/Q, is the statement P or Q true? Okay. So in this first row, P and Q are both true. When I ask, is P or Q true? Yes, P or Q is definitely true here. If one is true and one is false, when I ask the statement, is P or Q true? One of them is. Same thing here, is P or Q true? Yes, one of them is. When we move to this final situation though, and I ask, is P or Q true? No, neither of them are. So my statement P or Q would be false. Okay. So here, at least one statement is true. But in the end, neither statement is true. So for our conjunction, both have to be true for the conjunction to be true. For our disjunction, only one of them has to be true. So here, disjunction is true when at least one statement is true. Okay. All right, so let's try some more examples and we'll make it a little more complicated. We're going to construct a truth table for the following statements. And the first statement we're going to look at is P or not Q. Okay. So we have two statements we're combining in a bunch of different ways. We've got the statement P and we've got the statement Q. Okay. And again, same possibilities. They could both be true. One could be true, one could be false, one true, both false. Okay. Our goal is to get to the statement. Let's see. P or not Q. I've got P. The problem is I do not have this not Q yet. So before I can do the or, combining those two, I've got to find this not Q. So I also need a column for not Q. And going through and doing that, all that does, remember, is flip the truth values of Q. So I'm going to flip them, and it's going to be false, true, based off that starting value. Okay. Now we've got our statement P, we've got our statement not Q. We can go ahead and figure out, is P or not Q true then? So what we're going to utilize are these truth values. Here's our truth value of P. Here's our truth value of not Q. And so what I tend to like to do is I like to kind of run down in each column. Based off this, P is true, true, false, false. We're doing the or statement. And then not Q has the truth values false, true, true. Okay. And we're trying to see, is one or the other true? And based off this, one or the other is true. So this starts out as true. True or true? We've got at least one true. Here they're both false. So my statement P or not Q is going to be false. And now here, P or not Q, one of them is true. So this end statement is going to be true. So basically, you're using the values of these two common columns. To find the truth value of P or not Q. Okay. So the way you can kind of read it, if P and Q both start out as true, then after combining them in the statement P or not Q, I still end up with a true statement. If P starts out as true and Q starts out at false, after applying all these connectives, I still end up with a true statement when I say P or not Q. If P starts out as false and Q starts out as true, if I make this statement, I have made a false statement. If they both start out as false, when I make this statement, I'm making a true statement. Okay. So this is going to be really useful when we get to arguments in the near future. But let's try one more of these, get more practice. We're pretty much going to do the same thing, but we're going to change it to end. So P end, not Q. So the more you do these, the more you're going to be able at setting up those columns in the header first before having to go through. But if you like kind of just starting out, you've got P and Q. All of their possibilities are they could both be true, one false, one true, and then a false, false. Okay. Before I can do this end in the middle, I've got to find my value of not Q. And so again, I just go ahead and take these values and they get flipped. So it becomes false, true, false, true. Okay. And now that we have our value of not Q, we can do this end that is in the middle. Okay. So we can now look at the statement P end not Q. I'm going to utilize my values of P, my values of not Q to get this end statement. Let's go ahead and make our chart a little easier to see. So I like to first put my truth values of P down. That's true, true, false, false. We're doing end as our operation. And not Q is false, true, false, true. Okay. So we're using these two columns to determine the truth value of P and not Q. And for our end to be true, they both have to be true. They're not both true here or here. In this second row is the only place that they're both true. Okay. So now the question is, what happens if we have three statements? How many cases / possibilities are there to start with? Okay. So if you kind of think back to our combinations, we have three statements. Each of them have two possibilities. You have 2 times 2 times 2. You have 8 possible starting combinations for truth values. Okay. So we've got 3 statements, P, Q, and R. Okay. I know if I just have the 2, they could both be true. One could be true, one could be false, false, true, false, false. Well, one possibility is P is true for all of them. Okay. So you have your 4 starting combinations at the beginning here. Okay. So there are 4 combinations for these two statements. Okay. Then we're assigning P to be true for all of them. But the other possibility is P could be false. So really, I can copy and paste this and then go ahead and assign P to be false for all of them. So here, now we assign P to be false. Okay. And in total, that gives us all 8 possibilities. Let's go ahead and make our chart nice and clean and easy to see now. Okay. And that is every possible combination when we have 3 statements at the start. You have 8 possibilities for the beginning combinations. You go ahead and run through based on your compound then. Okay. So what we're going to do now is one more example of a truth table. And we're going to construct a truth table for the statement P and not Q or R. Okay. So remember, this means and. This means not. And then this means or. Okay. So I've got my 3 statements, P, Q, and R. And I have those 8 possibilities for their starting combinations. Okay. So they can both, we'll start with Q and R. They can both be true. 1 true, 1 false. 1 false, 1 true. False, and false. Okay. That runs through every possibility of Q and R. And for that, we can assign P to be true for all of these. Then we go ahead and copy and paste, and we can assign P to be false for all of these. Okay. So those are the fixed starting values of P, Q, and R. Okay. So based off of them all being true, I want to see, is this statement true? Based off this combination of their truth values, is this statement true or not? And that's what that end column of this chart is going to tell us. Okay. But to do that, I need a bunch of stuff I've got to find throughout the way. Ooh, didn't do that. Okay, let's just redo that there. There we go. I'm going to put another column now. Okay. So I need to get to this statement. I want to start by working in parentheses first. So I want to find the truth value of this first. But to do that, I don't have my truth value of not Q yet. So I want to make a column with not Q. Okay. After I make the truth value of not Q, then I can go ahead and see what about this statement in the parentheses. We'll have P, we'll have not Q. We can go ahead and find out whether P and not Q is true. So we can find this piece now in parentheses. Then once I have the truth value of this statement, I've got the truth value of R, we can do this whole statement at the end. So basically, I'm kind of preemptively prepping what I need for my truth table. We've got our statement in parentheses. Now I can see, is this statement or are going to be true? And then that is all I need to be able to complete this truth table. So I'm going to go ahead and make my table completely. All right. So I've got everything set up, and I'm going to continue down my chart in this direction. So this is fixed every single time. Anytime you start with 3 statements, this is what your first 3 columns should end up looking like. Now I want to find the truth value of not Q. So I need to look at my column Q to be able to negate it. So remember, not switches all of the truth values. So I could rewrite all of them in here if I want to. These are the current truth values of Q. When I negate it, it switches the value. So not Q would be false, false, true, true, false, false, true, true. Now I move on to the end. So for that, we're looking at P and not Q. So I'm going to look at P. I'm going to look at not Q. My values for P are true, 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 false, 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 false. We're doing the AND operation. And then I'm going to look at the truth values for not Q, which we just figured out. False, false, true, true, false, false, true, true. Okay. Remember, this is basically asking, is the statement in this row, or is P and not Q true for these values? And so they're both not true. That means this statement is going to be false. Both not true, false. Now they're both true. So that would mean this statement is true. Likewise, this one, they're both true. But for everything else, it's going to be false. Okay. Now I've got my P and not Q truth values based on each of these starting combinations. So I'm going to go ahead and put that here. Here's our truth values of P and not Q. And the operation we're going to do is OR. And we want to put our truth values of R in each of these rows. Okay. So those are nice. Those alternate true, false, true, false, true, false, true, false. Okay. And so I'm asking the question, is this statement or this statement true? So if I'm looking, is the first one true? No, but the second one is. So one or the other is definitely true. So as long as I see a T, I'm good. So this is true. When I move to the second combination, I've got false or false. That means the statement would be false. In the next 3, I have at least one T value. So the statement P and not Q or R would be true. I've got no trues in either of these, but at least one that appears here. Okay. So again, what this truth value tells you, or truth table tells you, is if they're all true, when I make this statement, I'm still telling you something that's truthful. Based off this combination of P, Q, and R truth values, when I make this statement, I'm telling you something that's going to be false. Based off these values, when I make this end statement, I get something that's going to be true. Okay? So this is really helpful when you're trying to do some type of argument. You're going to make a statement that's true. You're going to make a statement that's potentially false. Well, if I combine them to try to prove a point, am I telling you something that's truthful? I want that to happen.